Hey, hi, hello everyone. Are you able to hear me?
Yes, sir.
Yes, sir.
Okay.
Good evening, sir.
Good evening everyone.
Good evening, sir.
Okay. So I guess for the fourth week, one session has been done, right? So the summary has been done. So we'll just take the doubts today.
Yes.
Okay. I guess your paper is also in, I guess, next Sunday, right? Next Sunday you have your paper.
Yes, sir.
Yes, sir.
Okay. So before that, we'll be having some 2-3 revision session. I guess 2 revision session will happen. And
So I want to ask something, sir.
yeah, 1 second. Let me. So we'll be having some 2 sessions, a revision session, and those are like important that we should be attending. So if somebody is not attending, also you just ask them to attend those sessions, or maybe we watch it later. But those are like important. So please do watch those sessions. So I guess that will be scheduled. I guess I don't know if the schedule has been out or not, but it will be scheduled mostly in the upcoming 2-3 days itself. Okay. And then the mock also will be released, I guess. I don't know whether it has been released now or not, but it will be released in the coming 1-2 days.
Sir, already said 2 marks released again.
Okay. Then it's fine.
Sir, are you taking classes for maths and stats both?
Yeah.
Okay.
Hello, sir.
Yeah.
Due to some reasons, I am not able to give 7th July qualifier. Then I am. I will I eligible for next one?
Next month. Next
Next
month.
next one like
Yeah, bro. Yeah.
Okay.
Reattempt, or what you're asking?
Okay.
Okay. Then
Like form
we'll start taking the doubts. So you can just start with the practice assignment. So wherever you have a doubt in practice assignment, and then we'll go to the activity questions. Okay. So whichever practice, and we'll be just discussing about the fourth week content. Okay. Because for the remaining weeks, I already told you for the mocks, we have already scheduled a session. So there we'll be solving all the mocks question. We have some revision session also where we'll be just discussing all the concepts from week 1 to 4 again. Okay. So today we are just going to discuss about the fourth week. Fourth week, wherever you have a doubt, we'll just start with the practice assignment. Okay. So whichever question you have a doubt, you can just ask me. We'll just solve those questions and then we'll move to the activity questions. Is that fine to everyone?
Okay, sir.
Yes, sir.
Yeah. Let's start. Then which question you want me to solve? Practice assignment.
Sir, I
So
have a problem in the concept, sir.
okay.
So, in the association between the categorical and the numerical data, there's that biserial correlation coefficient. I have a problem in that. Means I can understand the formula.
Okay. So what to understand there? You just have to like the formula you have to somehow mug up and then you can use it directly. What's the issue
But
there?
what is that y bar, y0, y1? That concepts I'm not clear. Means y means where we will get that values of that variables.
Which variable you're talking about? Why not? So okay. So first of all, you know the formula, right? And
Yes, sir. Yes, sir.
so so first of all, the discussion that has been done is very minute, like for the category, the relation, how can you relate the categorical and the numerical? Okay, just the if you just know the basic formula that has been taught, I guess that has been taught in the very last lecture, and that too very like it's not that elaborate. Okay, so if you're just because this here we have just talked about any categorical and the like how can you relate or what's the relation between a numerical and a categorical, and that categorical also we have just specified that the categorical also should be having like only 2 categories, not more than that, correct?
Yes, sir.
Yes.
Yeah, so
Yes, sir.
correct. So that's why I'm talking about like you don't have to worry about from where this has came and all those stuffs. Okay, is that fine? Okay, if you are having problem in understanding the concept behind that or the formula itself, like from where did it came or something like that.
Really, the thing is that the last video that we have got regarding this topic, the entire thing was explained in the Google Sheets. So there, it is already preloaded, the formulas.
Correct. That's why I'm saying you. That's why I'm saying, because that has not been taught in a very elaborate way. So mostly the questions will be asked very basics from the formula itself. Okay, as it has not been discussed in a very elaborate way. So that is what I'm saying. You don't have to worry about that much. If you are able to solve at least some problem, understand a basic idea about how can we relate a bit, like if the value that I'm getting from the formula is very small, how can I relate with those categorical with the numerical? If the value is very high, then what are the what can I what does that imply? If you are aware of those simple things, you are ready to is fine for you. Okay.
Thank you, sir. And
Yeah.
another thing, since the questions that we will be facing in on 7th of July, the questions will be like the pattern we are giving, we are submitting of in the graded assignment.
Yeah, that will be more or less on the similar level. But if you want to get the exact idea, you can just try out some of the previous term paper. Okay, maybe the previous last term paper, you can just try it out. That will be almost same pattern, same level of difficulty you can think of, same number, almost similar number of questions, similar pattern of questions you can get, or maybe you can get an idea from the mock also. So mock can give you an idea, or maybe the previous term paper is the best friend in sense of if you just want to get the whole paper idea, because the graded and all, each week you'll be you are generally asked. So some of the questions are really difficult to solve. Okay, but if you'll just go through the previous term paper, that will give you an idea with how much difficulty of questions can be asked. And yeah, so more or less some of the questions can be similar, almost similar to the graded also. So if somebody has not solved graded or practice, I'll urge you to solve at least the graded assignment and solve like the practice assignment at least once before writing the exam. Okay,
And
so
sir, anything related to the Google Sheets will be given to solve, or we
no,
will be...
there won't be anything related to the Google Sheet. So whatever the formula, some of the formula for the Google Sheets are different from whatever we are using. So nothing will be asked regarding to like the percentile itself. So those are different. The formula that can use the Google Sheet can use the different type of formula. So those won't be asked. So regarding Google Sheet, nothing will be asked in the exam.
Sir, is the calculator allowed?
Calculator is not allowed, but you will be having like wherever you will be writing the exam, that PC will be having the inbuilt calculator that we'll be using. Okay.
Okay, sir. Sir, what is meant by absolute value of the point that is biserial?
So can somebody, yeah, please mute yourself, everyone, and let's start whatever the doubts you have. So I guess I've just gave you the brief idea about the exam, and that is well and good. In the revision session, maybe we can dig it more, but as of now, we'll just stick to the weeks forward. Okay.
Sir,
Yeah.
can I ask?
Yeah, you can ask.
Sir, absolute value of the point biserial correlation coefficient of association.
Okay, so you are asking the same thing, right? So the relation between a categorical and the numerical value. This is what you are asking.
Sir, what is meant by correlation coefficient of association?
Okay, correlation coefficient you already know, right? Correlation coefficient, how, like if you have basically two numerical variables, how are they related? Like how it's generally basically the correlation is what? Can you see my screen? Are you able to see my screen, right? Is it visible? No.
No, sir.
Okay, one second. Is it visible now?
Yes, sir. Yes, sir.
So this is simple, right?
Yes, sir.
Generally, correlation is just a measurement. We generally measure the measurement of the linear association. Linear association between two numerical variables. Two numerical variable. So let's, for example, I'm giving you some data sets. Okay. So there can be some data set. Okay. So, and you have to just think of one. So whatever the data set I have given to you, that generally has person name and then their weight and the height. Okay. So, and if somebody asks you, like whenever you'll just try to plot this on a scatter plot, so this weight upon the height, okay, you just need like how does that weight is related to the height, okay, or the height is related to the weight. So normally it happens like if the height increases, the weight increases, right? So in this case, how can you like, so for this case, whenever you'll calculate for any data set, so whatever the data set you are getting, so what should be the correlation coefficient? If I'm just asking that the weight and the height is highly correlated, that means what should be the value of this correlation coefficient for this data set? What do you think? It should be closer to 1 or 0. What should be the value? Or
One.
what?
One.
Yeah, correct. So
One.
it should be, yeah, it will be very much closer to, let's for example, the value would be from 0.1 to 1, right? Because I already told you many a times, like mostly whenever you, and you can assume also like the weight and the height will be highly correlated because as the one increases, the other will increase, right? So correlation coefficient basically will give you an idea about how does that, like whatever the two numerical variable that you're comparing, okay? And just want to know how this is related, linearly associated. So that will give you the value of correlation coefficient will tell you about that. So whenever the data, whenever the value that you are getting, this R value is closer to 1, that means it is highly correlated. Highly correlated means one increases, the other also increases. And if this is closer to -1, that is like really, so that is also highly correlated, but in the negative sense. Like that means if one is increasing, the other is decreasing. Okay. But if this is closer to 0, that means it is not related at all. Like, so the whatever the x value is, let's for example, any two random variable or not random variable, any two variable, or you can say the features of the data set, okay, that is totally not related at all. Okay. So there the correlation coefficient will be around 0. Did you get an idea about this?
Sir, can you give me with an example of weight and height?
Weight and height, I told you, right? So whatever the weight, let's for example, the weight is something like, so I'm not choosing the exact weight, like the unit. So you can just think of as a correct unit. So whenever the height is in some case, like let's for example, the height is 3. I'm not saying anything about the unit, but you can just assume that is some unit. Whenever the weight increases, let's for example, this becomes 50. The value height also becomes 4. If this is 20, this is 5. So you can see that as the value of one increases, the other also increases, correct? So in this case, you can say that if you have been given this type of data set and the options has been given to you directly as 0.3 or r equals to 0.04 or r equals to 0.95 or r equals to, let's for example, 0.2. You can directly say that from as the value of one of the variable increases, the other variable is also increasing, right? So you can directly say that it is linearly highly correlated. Okay, so this generally the correlation coefficient generally captures that thing itself, like how the two data sets are linearly correlated, how much that is linearly related. Okay, and you can, if you want to plot this, right, if you just plot this data also, you can just think of as a height here and then weight here, right? So let's for example, this 3. So as compared to 3, it was 10, and then compared to 4, it increases. At compared to 5, it increases, and compared to 6 also it increases.
Sir,
Right?
have you got 0.95?
No, I just gave you one example that if this is the given data and the options are given in such a way, then so from the plot itself, see if the plot is somewhat like this, I don't know, like whether your
Sir,
concept
without
is
choice,
clear.
they are asking us to predict the value.
What?
Without giving options, they are asking us to write the value. Means how can we write, sir?
Yeah, you can write it, right? If you have been, see, let's for example, I'm giving you this type of a link. So the data set is somewhat like this, okay? Okay, the scatter plot are like this. You can see the scatter plot, this plot. And if I'm asking what should be the value of this this data set, this scatter plot that has been plotted, let's, for example, this is some X variable and this is some Y variable. How X and Y is correlated? What do you think? So what should be the value of R? It will be like, you can directly say that, right? It will be much closer to 1 because this data point generally resembles this linear straight line, correct? Can you please mute yourself, whoever is talking?
Sir, R resembles the slope or what?
हरामी तो है बाप
Can you please mute yourself? Like, you can just
हरामी तो है बेटा तू ना वो बात नहीं लेकिन हरामी तो है हमारे
Voice from coast.
Sir, can you please mute your
please mute yourself.
Yes, sir.
Sir, you are unmute.
Hey, I was, nobody's there in my check. So I'm alone at my home itself. So nobody can talk from. So, so what I was saying is, if you have been given some two, see, correlation is like pretty simple. How the two variables are correlated to each other, related to each other. Okay, if the value, so whatever the data that I have given to you, if one data is increasing, the other is also increasing, right? So for example, if the height was 3, some unit, then the weight was 10. And similarly for 4, it becomes 15, for 5, it becomes 20, and for 6, it becomes 25. So you can see that it is somewhat like, it's a straight line, right? It's like resembling, the data point is resembling some form of a straight line. It's like straight line, I mean, it is increasing, like one value is increasing, the other is also increasing. So the data set, you can think of in this way, right? Like somewhat like this. So that basically resembles some sort of a straight line. So this data are not all the data are on some straight line, but at least that it resembles a straight line, right? Or not? This again, if I'll unmute you, like somebody will just speak out something.
Hello, sir. Hello,
Yeah.
sir. I was asking that
Yeah, have you
R is
understood?
related to
Yeah.
slope. Now, slope of a straight line is directly proportional to the correlation.
Yeah, you can say that. Yeah, correct. You can say that. Not the exact word, but you can say that. It's like related to that.
Because if the correlation is negative, then the slope is also negative, and when it
And
is
how is strong?
positive,
Yeah, correct. Yeah, so in that way also you can say that. Correct. Not exactly the word slope, but you can say that the R, if the R is very high, that means it is like
the
close
slope
to
is
1.
also high. If R is nearly 1 or less than 1, the slope is very high. If it is
No,
not,
not, see, directly you can't say that R is a slope itself. Okay. But you can say that if the R is very much closer to 1, you can say that the values are very highly correlated, X and Y. That means if X increases, Y also increases. This is what that means. Okay, if R equals to -1, that means the data point is highly correlated, but in negative sense. If like, that means what? If the value of X increases, the value of Y decreases every time. Okay, and if the value of R is very much closer to 0, that means X and Y is totally unrelated. Like whatever the value of X is, you can get whatever the value of Y. Okay, there is no relation between X and Y.
yes, sir, it means they are not synonymous, but somehow they give the idea for each other.
If the value is very much closer to 0, you will not get anything from X. If you just want to get something from the, if you want to get one variable and you want to correlate the two variables, you will not be getting anything if your R is very closer to 0. That means both the data set are very highly uncorrelated. Like, it's not related at all. So you can't assume anything. Like, you can't make any assumptions from the other variable. Okay, but if the value is very high, like there is a very high correlation, right? In whenever you will do the ML model and all. So if you have basically two data sets which are very highly correlated, okay, so you can just remove one data set like that. If you are not able to understand that, that is totally fine. But this is what basically in the future courses it will help you.
Yes, sir. Understood, sir. Thank you.
The association between the gender and the salary, sir.
Okay, so that is totally different. That is like basically you are, in that case, basically you are just calculating. You just want to take an idea about how does that your one category, like one basically the one you there also You just want to correlate two variables, but in that case, your one variable is a categorical variable and the other is a numerical variable. Okay. For that case, I told you, right? In the starting itself, I told you just need an idea about the formula. Okay. So whatever the formula, can you tell me the formula for that case? You just need the
Yes, sir.
basic
Y
formula.
naught minus Y1
Y
upon the
naught
standard deviation of X1 under root N
Under root.
0 upon N into T naught of T1.
P1.
Yes,
Okay.
sir. Where T naught
And
is
what does that P1 is
N0
basically
by
tells
N.
you?
Number of
Yeah,
observation of O
yeah,
upon
N
total
naught by N,
observation.
and then
N
P
naught
is also
N1 upon N.
N1.
Yes, sir.
Okay, so this basic idea you should be having how to calculate if you have been given a categorical, like you told, right? How does that gender and the salary, if been given some data set where the salary for some two different genders has been given to you, and then if you want to check whether there is any correlation between the gender and the salary or not, so you can use this formula to get. And here also, if your value R, again the R value, if it is very high, then you can say that there is a strong relation. But if you the value again you are getting very closer to zero, then you can say that the salaries that the people are getting is like it's not dependent on the gender, whether it's a male or a female. The salary doesn't depend on the gender. If your value, whatever you're getting, is very closer to 0, 1, something 0 and 0.1, something like that. Okay, let's for example you're getting something like 0.01. So that means the gender is irrelevant for getting in like the salary. Okay, this is what it means. And if the R is very closer to like 0.9, then you can say that there will be a very highly gap between the salaries for the male and the female. Okay, so in those cases you'll be getting R as a very closer to 0.9. Are you getting my
Yes,
whatever
sir.
I'm saying?
Yes,
Yeah,
sir.
okay,
Yes.
okay. Yeah.
So what
So,
Sir, I got
the relation between correlation and slope? Like how are they related?
no, and I don't think so. Those are taught. Are that taught to you?
So no, I'm just
no,
asking.
not yet.
So
Not
if it's
taught
not,
that is
yeah, so don't have to worry about that first of all. Okay, R square you have been taught, I guess, right? So but R square is basically if you are having a best fit line. So best fit line and all, if I'll start teaching you, it's not relevant for exam. See, best fit line and all, you basically it's a basic type of a regression problem. Okay, in ML you'll be reading about a regression. Okay, how do you fit if you have been given a data set? Those are like
Excuse me, sir.
Yeah.
Yes, as for the association between categorical and numerical value, how does the value of R relate to the the association between the variables? I haven't been able to understand. Can you
No,
please
I told
explain
you,
that?
right? I told you one thing, right? If you are calculating from this cases itself, if you have like one beautiful example has been given, right? So like the relation between if you have been given two categorical data, there one is gender has been given and that can be male and female. Basically, you just have to deal with a data which has only two category. Okay, till like whatever has been discussed for your course. Okay, we are not discussing about anything else. For your course, it has been discussed. You just have to get an idea about how they how two variables are related. In that two variable, one is categorical, and in that category also, you just have a two variable, like two category, or you can say, okay. And then the other is the numerical data set, and then the numerical data set is talking about the salary of a person. So now if you have been given this type of a data set where you have been given some 50, 100 people name with like out of that maybe 30 can be like female and some can be male, and then you have been asked to check whether is there any relation between the gender and the salary, because like you can be told about if you're just working as a data scientist, and then you can be asked to just correlate whether the males are getting more salary or the females are getting more salary. Is there any relation between the salary of a person and the gender? So then you can use this basic idea formula and then get an idea about the R, the correlation between the gender and the salary that has been given. So one can be numerical, the other can be categorical.
Is
And then
the
if you are
range
getting,
between -1 and 1 as in case of the Pearson coefficient?
so here also you'll be getting the same values from if you are just putting the mod here, then the value will be from 0 to 1, and if you're not taking the mod, then it will be from -1 to 1.
All right. And
Okay.
the same as the same association, like it happens. Like suppose if it is
Yeah, it's
closer
the
to
same
1, then
association. Correct. It's the same association. I can give you an idea of like if I'll just write it, it'll take a lot of time to just do the calculation. But the same thing you are doing, like the same. Okay, if I have the example, I guess in the book stats, let's deal with one example. I guess this is the example that has been given in your book also. Okay.
Give the example.
What do you?
Example.
Okay, I didn't get you. Whatever you're saying. What exam? Exam? Okay. In the this type of questions can be
She
asked
is
in
saying
exam. This
that
is
give
what you are asking.
example. She is saying
Okay.
give example.
Okay. Got it. Sorry. My bad. Okay, so this is the example. So here it has been given. So you can see that the gender and the marks has been given, and then you have been asked to see whether there is a relation between the gender of a person and the marks that they are getting. Okay, whether the females are getting more marks or the male are getting more marks. So the data has been given to you. So the first thing that you have to do is the first step. What do you do? Can somebody tell me what do you do in the first step? So you have the formula.
We
Okay,
assign either male 0 or female 0 and the other one 1.
Correct. So you assign something, right? So from the formula itself, you can see that something is y0 and something is y1, correct? Okay, and then something is p0 and p1. So you just, from the gender has been given to you, you just put one female as 1 and the male as 0. Okay, something like that you do. And then whatever, so you have to calculate some y0 bar. And y0 bar, what do you mean by y0 bar and y0 1? So
It is a mean
just,
of observation of
correct.
0 and
So
1.
yeah, correct. So for the male, you just split this into two. So you'll be having a two category itself. So one for a male and one for a female. So you calculate the mean for a male. Okay. Similarly, you calculate for the female also the mean score that they are getting. Okay. So you'll be able to calculate that. So you have to put it here. And then you have the numerical data set, right? So for the numerical data set, you calculate the standard deviation. And then P0 and P1. P0 is basically the proportion of male, okay, in the whole data set. Out of 20, how many are male? And similarly, you'll calculate for P1, you'll calculate the proportion of female, okay, and then put it here. So here it has been calculated. So they have taken male 0 and then female 1, okay, and then whatever. So can you calculate P0? So P0 is basically 1, 2, 3, 4, 5, 6, 7, 8. So 8 out of 20 people, okay, are male, and then the remaining are female. So this is the proportion that you have got. Similarly, you can calculate y0 bar. So basically the mean. So summation of all the values, all the marks that the male has scored upon the total number of people that are available as a male. Okay. And similarly for the female also, you can calculate it, and then you can calculate the mean. So it has been calculated here. You can see that the data has been calculated. Now the proportion also has been calculated. The standard deviation for the marks also has been calculated. Now if you put it here, you'll get the value here, 0.188. What does that mean? Can somebody tell me if the value is very much closer to 0? Okay, what does
They are
that mean?
not correlated that much.
They are not correlated.
Correct. So that means what? The marks that the people are getting is not correlated to their gender. Okay, this is what it means. Is this clear to everyone or not now?
Yes, sir.
Sorry, can you please repeat the last
clear.
statement?
Okay, what I was saying is, so the value you have calculated everything, and after that, after calculating all the values, so you have calculated this correlation like for a category and a numerical variable. So you have calculated, and the value that you have got is very much closer. You can see that this is closer to 0 or 1. It's closer to 0, right? Okay, so now you can say that the marks the people are getting is not related to the gender. Okay, so this is what has been told.
Oh yes. In the case of no association.
Yeah, so the association is like, or you can say the relation is not very high. Okay, it's very weak relation between the gender and the marks.
But in the
So,
previous class, we've learned that there is no sort of linear association, but it is not that variables don't have an association.
what linear association?
That in case if the R value is closer to 0, then there is no sort of linear association. That is correct, but it does not mean that there is no association of that sort. There can be other sort of
That was correlation. There was the mod was not present there. Mod was not there and it was correlation.
Sir, then what was
thank
the mark it should be then which is correlated?
What was?
So when we can
If
say
the,
that they are weakly correlated.
if the
When it
values
is
are
What
very
is the
near to
mark
closer
for
to
that?
1,
I
if
mean
your
the
value,
name.
if the values are closer to 1, or you can say more than 0.9, 0.85, then you can say that the values are highly correlated. That means you can say that from the data itself, from the mean, calculating the mean itself, you can, or from whatever the value that you have calculated, RPV, after calculating this, if the value that you are getting is more than 0.85, maybe more than 0.8, then you can say that there is a very partiality, like the marks that the female are getting are higher than the compared to the male, or the vice versa, depending upon whichever is scoring more. Okay, so whenever we'll do the scatter plot, only the scatter plot, and then you'll just plot it for a male and a female, from there itself we'll get an idea. So if the correlation is very high, then you can see that the female are scoring here. Okay, let's for example this from 0 to 100 marks, and then male are scoring here. If the values, and that can be opposite also, maybe the male values can be here and then the female values can be here, so anything can happen if the values of R is very high, like more than 0.85 or 0.9, something like that. Okay, got an idea, right? And I don't know why there is so much of confusion in this. Like, this is pretty simple, right? I told you. So you just assume. So, can you please mute yourself, otherwise the session will...
इधर वो गोल किया ना उसके अंदर. Sir, please mute Devendra Soni particularly, not everyone. Sir, please mute only Devendra Soni, not everyone.
Okay, so let's is this clear? And
So
see,
what
in the
will be
exam,
the value when they are weakly related?
I told you, na, this is weakly related only, very less, closer to 0, then they are not related, like they're very weakly related. This is what you can think of. Okay, at least for the category, whatever has been given to you and the marks is very, like the correlation is very low. If the R is closer to 0.1, something like that, that can be related to some other category, but we don't have to go in those cases. Whatever has been given to you, the category, the gender, and the salary, or whatever the marks, if the values that you're after calculating the RPB, if it is very low, like close to 0, then you can directly say that they're not highly, like they're basically not related, less related at. Okay, is this clear to everyone? And
Yes, sir,
mostly it
clear.
will not.
Yes.
So very basic questions will be asked if they are asking something from the RPB. Okay, so you don't have to worry much about
Sir,
this.
in mock
What is
test,
the
the 5-mark question was
between
there for
Celsius
this.
and temperature, sir?
Okay.
What was?
Sir, I have a doubt, sir.
Okay, so for 4th week, wherever you have a doubt, you can just ask me. Practice question.
Sir,
And are you guys solving the practice assignment or not?
Sir, I
Because
have a
you
doubt.
can get a
in that
direct
only,
question
sir.
from the practice or the graded itself. Okay.
So what is
Completed,
the
but I have a
correlation
doubt in week 3.
between the Celsius and
Not a
temperature?
question, but
Week 3, I told you like how many should, like time I should repeat. From week 1 to 4, we'll again have a 2 sessions. There you can ask all the doubts. In
sir,
the
I have
revision
a
session,
doubt in a concept, sir. If you get
that
5
also
minutes
will be
also,
like,
then
yeah, those
Yes, sir.
concepts
Even I
also.
have a doubt in a concept from week 3.
sir,
Week
if
3,
you
I
have
told you
5
week 3.
minutes, then please explain why make
Or
wait.
at least
I'll
at
solve
the end of the
something,
class,
sir.
if you could give us.
Week 3, I'm not going to discuss today. Maybe in the end, I'll discuss after finishing week 4. Okay.
So when
Hello, sir.
Can correct the answer, sir.
Yeah.
Hello,
Yeah.
sir.
Yeah.
Sir, can you tell me how to attend the EMQs?
So for the EMQ also, I got information that for the EMQ, so you don't have to like worry about the EMQ. EMQ, everything will be getting started from your week 5. Okay. So we'll give you an idea about the week 5. After that only, you'll get any problem.
What is it?
In the practice, if you'll just open the practice assignments questions, there are some, I guess, EMQ questions. So in those basically EMQ questions, whatever the concept has been, so you have been given some numbering, okay? Whatever the concept that you're using to solve those cases, like if you have been given one question, and then some topics have been given, so you'll be using median or mode or mean. So those are things has been given to you. So you just have to mark out those numbers, those you will be using to calculate, okay, in that question. Okay, this is what EMQ means. But even though that is not relevant till week 4. From week 5, maybe you will be asked some questions. Okay.
Sir, I have a doubt
Okay,
from
sir.
activity 4.7, question number 1.
Okay. I'll just week 4, right?
Week 4, yes, sir. Yes, sir, week 4.
Sir, before going over there, sir, can you please answer my small doubts? Sir, suppose sir, we discussed about the value tending towards 1. So there is a very strong correlation and both the things are very much related to each other. What can we comment if the value is tending towards -1?
That is also very highly correlated in a negative sense. That means if the values of 1, like for example, you can just think of as like ma'am was giving an example, right? So you have this, or maybe you can think of as an example, right? You're using some car, okay? One car you're using. So every year that there will be some depreciation in the car, right? And then the price of your car will decrease every year, correct?
Yes, sir.
Right? If you want to sell it now itself, like if you have some car and then if you want to sell it 10 years later, the price will, because of that some depreciation in your car, the price will decline. And similarly, if after 20 years, the price will further decline. Okay. So if you just try to correlate, then we'll be getting the value of the R as very large value, but in the negative, like -0.8 or something like that. So that means if the value, like as the year increases, the price of your car decline very fastly. So in that way, you can think of. Okay.
So even if it tends towards +1 or -1, the relation
it's
will,
like, correct. So only the thing is, 1 will be somewhat like, you can see my screen, right? 1 will be like
Yes, sir.
this. So 1 will be like, here the R you can think of as a positive, and here you can think of as a R as negative. But strong relation is there, okay? Between
both
X
will
and
hold
Y.
the strong. Both will
Yeah.
explain the same thing, sir. A strong relation. Okay, sir. Thank you.
Strong relation. Okay.
Thank
you. Okay, so 4.7, somebody was asking. 4.7. I'll have to.
Sir,
Yeah.
sir, I have doubt in 4.6, question number 2, sir.
No, 1 second. I'll just discuss 4.7 and then we'll go to 4.6.
Sir, I got my answer. It was actually typed the wrong ones.
Okay, no problem. Then let's move to the 4.6
Okay, sir,
you're
thank
asking,
you.
right?
Hello. Yes,
Yeah,
sir.
4.6, who asked 4.6? Question number?
Sir, question number 2. What is unit of covariance, wala, sir?
Okay, so unit of covariance you already know, right? What do you mean by covariance? What do? You just take the, how does that, basically in the covariance you have basically 2 variables, right? Okay, X and Y. Let's, for example, you're just dealing with the covariance of 2 variables, X and Y. Okay, and then, so basically there you will be having 2 different variable. So if the two,
Sir, screen is not visible, sir.
Please use different color.
Okay, so can you see this, whatever I'm writing? Is this?
Yes, sir. Yes, sir. Yes, sir.
Allah is good. Okay, so which option you're like, which question you're talking about? Question number, which one? 2 or 3?
2.
Okay, see, okay, so the covariance, what is the formula? Just tell me the formula for the covariance. How do you calculate
Deviation
covariance?
from means or upon.
Basically the deviation from the mean, right? Or for both the
X and Y.
both the variable, right? For both the variable, you calculate the deviation from the mean, correct? This is what you mean by covariance, correct?
Yes.
Yes,
Yes,
sir.
So X minus X bar something, and then Y minus Y bar.
Y
So if you
minus
have to
Y
just
bar.
calculate
Divided
the
by
Divided by n minus 1.
N or N minus 1.
okay, that is basically depends upon whatever you are dealing with,
Population of
population.
sample.
Yes.
Okay, now you tell me what should be the unit for this case? There should be some unit, right? If this is a variable, let's, for example, this is weight and this is height. Okay, and if I want to know about how does this, what is the covariance between the weight and the height? Okay, so there will be kg. Okay, and then here it can be anything, centimeter or feet or whatever. So basically this is the product. Basically, whenever you are getting the covariance, that will be basically the product of 2 cases, right? Whichever the variable that you are dealing with. If the one variable is the weight and the other is the height, then just the product of both the cases, that will be your unit, right? Is this clear to you? That's
Yes,
why
sir.
after
Yes.
we were, so covariance was not giving me much idea because of the unit, right? Because if I just have to compare two things, both are having the different unit, we can't compare it. So we went to correlation coefficient because, and then divided with the standard deviation. After that, the unit went away. And if you are having, so whenever you calculate something, let's for example some index. So why do we
standard
calculate some
deviation
index?
has, sir.
We calculate some
standard-
sort of an index where there is no unit, so that we can compare two things, right? So that's why we went from covariance to the correlation, and the correlation coefficient doesn't have any unit. That's why correlation coefficient gives us a better idea about the two, like the relation or the how does the linear relation between two variables. Is this clear? So covariance will be having a unit that will be the product of two variable, whatever you are dealing with. Okay, x and y. If the x is having some unit u1 and y is having a unit u2, then the product of two u1 u2 will be the unit. Okay.
Sir.
So any other problem? Any other problem from the
Sir, there's
activity?
a question about Simpson's paradox.
Sir, I have a question on practice assignment.
Sir,
Question number 3 solved.
sir, but how this
Question number
second
3 in the
question is
same
being solved,
4.6.
sir?
Question has been given the unit of the covariance. What can be the unit of the covariance if one of the variable is kilogram and the other is meter? So we'll be having the product of those two.
sir. Product.
Sir, question number 3, 4.6.
4.6, question number 3. What is this? Calculate the
sir.
covariance. This is simple, right? Calculate the covariance now. Covariance, like you just calculate x mean. What will be the x mean? 2 plus 4 plus 7 plus 1 upon 4. Whatever you're getting, you just calculate what are the deviation. So what are the values that you are getting, x bar. You just calculate the deviation from this x mean. 2 ka deviation calculate karo. Then you calculate the deviation of 4 from the mean. Okay, 4 minus x bar. Similarly, you calculate the deviation of 7 from the x bar and then 11 from the x bar. Do the summation of all those. Then do the product with what? Then calculate the y mean. Y mean, whatever you're getting, 30 plus 49 plus 60 plus 65 upon 4. Whatever the mean that you are getting, you calculate the deviation from y. Okay. And then you just do the product for each case. Like do the product and do the summation. You'll get the covariance.
Sir, this y, should it be in ascending order or this order is okay?
No, any order is fine for calculating the covariance.
Sir, I'm having doubt in activity question. Activity
question
6,
number?
the very first question. Like it says that covariance between two variables is negative, and the correct option to that is
Question
both
number?
move
Question
in
number?
the opposite. Very
Question
first
number?
question.
No, which one? 4 point?
4.6.
4.6. Okay, first question. Okay, what's this?
It
When can
says
be a
that-
negative? When can this be a negative? See. When can this be a negative? The product will be negative.
solved again.
When can this be negative? Can you tell me? See, for example, if you have a data set, right? Okay, if a data set something like, so let's for example, this is a mean for one variable, and let's for example, this is a mean for one variable, this is a mean for the other variable, correct? And if you are just thinking that, you can think in this way, if it has to go in a negative, what does that mean? Both will be in the opposite direction, right? If one is increasing the other, so if the deviation
Yeah, I
explain
got it.
got it, right?
अगर same sign रहेंगे तो yeah, it comes negative.
हाँ, अगर सेम साइन रहेगा, अगर माइनस माइनस है तो पॉजिटिव भी रहेगा, और इवन पॉजिटिव है तो पॉजिटिव भी रहेगा, और देयर इज अ हाईली like you can say the correlation is also high if both are going in the same direction. Maybe got it, right? Yeah.
I got it.
Sir, I have a question on practice assignment.
Question number, which one?
4.1 practice assignment, question number 5.
Okay. क्या इसमें क्या है questions? What is that? If the values of the explanatory variable, okay, x is high, and the corresponding value of the responsive variable value is low, okay, then x and y are what? Can you see my screen? Okay. What is the issue here? I told you, right? I gave you an example. कि अगर, let's for example, years is 1 years, and then this is the price of your car. So price of your second-hand car, whatever you are using, okay? Price of the car that you are using. So every year the price will decline, right? So one thing is increasing, but the other thing is decreasing, right? So this is what? This is negatively correlated, right? This is correlated for sure, but negatively correlated. That means the R value will be much closer to maybe negative minus 0.8 or something like that. Okay? You got it?
Yes, sir.
Yeah.
Yes, sir.
Sir, I have a doubt in 4.7 question number 6.
4.7 question number 6. Okay. What is this? If the sample variance between X and Y is 45, sorry. Okay. So covariance has been given to you. And then the sample variance also has been given to you. What is sample variance for the Y also? You have to calculate the sample correlation coefficient. So I guess there should be some formula directly that you can use it. Is there any formula that you can remember? What is the formula for this R correlation coefficient? Can you tell me?
The covariance divided by the
By sample mean of two variables.
sample variance.
Correct. And then you just divide with something, right?
The standard deviation of both.
Standard deviation
Standard
of X
deviation
and
of both the variables X and
Standard
Y.
Correct.
From sample variance, you can calculate the standard deviation.
Yeah, from sample variance, you can calculate the standard deviation, right? And then you can put it here. You'll get the values. Correct? Or no? Is this fine?
Yes, sir.
Can you explain again, sir?
Okay. Next problem.
Sir, I have a doubt from 4.7, sixth question. I mean, sir,
4
third
point?
question.
7, fifth question.
Third question, not fifth question, third question.
Third problem. What is that third problem? The relationship between the covariance and the correlation. So what's the doubt here? So what is covariance of, what? Covariance, Samson. What is R? Covariance of X and Y?
Sir, I'm sorry, sir, it's 4.6, sorry. 4.6
Okay,
third
okay.
question.
Okay, no problem. 4.6.
So I got the answer as 29.25, but the answer is 39.
Oh, okay. So here you have to calculate sample variance. N-1 you have to use everywhere.
Yes, sir.
Have you done that? Okay.
Yes,
Then
sir,
also,
I've done that. Then also I'm getting as 29.25.
anyone else is getting 29.25?
Yes, sir.
Yes,
What you got?
29.
29. Let's. Okay. Let's calculate this then. Sample variance we have to calculate, right? If you have X bar 2 plus 4 plus 7 plus 11 by 4. Wait. What do you get here? What will you get here?
6.
6. Okay. Y bar.
I got 39 on this one.
I
I
guess
also got 39.
So maybe the calculation error. Let's plus 49 plus 60 plus 55 by 4. Calculate this.
48.5.
48.5.
48.
Okay. Now you calculate now what's the deviation that you're getting. X minus X bar product of Y minus Y bar. You calculate it, how much you are getting. For the first case, how much you are getting. And the order should be correct, right? The order
74.4 minus 1.
How much?
So 74.4.
74 point
-1.
-1.
Minus, sir, it is for all the 4 data, sir.
Oh, all the 4 data you have.
Yes.
Okay.
Yes.
So for both the cases you have calculated, you are getting 74.4
-1. Right,
minus
below,
1.
sir. No, sir. Right below it, sir. Right below it. Row wise.
This is for X or say this is the product, right? X dot.
Yes, sir. This is the product for the first row, sir. There
Upon
are 4
3.
rows over there. No, sir. I have not done the addition, sir. This is for the first row only, sir.
Oh, this is for the first case. Okay, 74.4.
Then it is -1.
-1.
And then it is 11.5. And that is 32.5, sir. Upon 4 -1.
Yeah, you will be getting something. You can calculate like
39.13.
So this is how you'll calculate. So calculate now 2 minus 4 and then 30 minus 48.5. Whatever the product that you are getting, this will be the 74.4. And then similarly 0.5 from here and then 4 minus 2. That is basically how much you are getting. 4 point, so minus 2.
Yes, sir.
You got it, right?
Yes, sir.
Yeah.
Sir, I have another doubt. From 4.7, the last question, 6th one.
Yeah, so 6th one. Okay, 6th one we have already discussed now, but I'll tell you again. So you have been given the covariance has been given, the sample variance is given, sample variance for the X, Y, everything has been given. So you have formula, right? So what is the formula? Basically, this covariance of X, Y upon standard deviation of X and Y, right?
Yes, sir.
So you can get the standard deviation of X from the sample variance of X, and similarly standard deviation of Y from the sample variance of Y, right?
Yes.
Similarly, covariance has been given. You can calculate the R, right?
Okay, sir. Yes, sir.
Yeah. Next question.
Sir, what is the proportion in contingency table, sir?
Oh, for the contingency table, so let's, for example, I'll just give you an idea. So the same example I'll give you, or maybe the book will be having the example like this. So where is that? Okay. So let's, for example, so one example was given to you that what's the proportion of the portion of so what's the proportion that so there was a data related to, so there was a data related to some male and a female, and then the data was related whether how many so the number of the count was given, like how many females is having their own phone and how many of them doesn't have their own phone, right? Similarly for the male also the data was given to you. Okay. Yes. Now you have been given, so this is basically the contingency, it's just a fancy name for the table. Okay, and then if you have to calculate the proportion, so basically there can be 2 types of proportion, right? So the first proportion can be in the female itself. So whatever the data regarding the female itself that has been given to you, what is the proportion of the female itself that has their own phone? Okay, that will be what? That will be basically what? That will be
30.
So yeah, 34, whatever the 34 upon the total number 74 is the proportion of the female that is having their own phone. Okay, and the remaining 1 minus 34 upon 44 doesn't have the phone. So that you can say as a proportion of the female that own the smartphone. Similarly, you can calculate for the male. Okay, and there can be one more. So this basically you call it as a row frequency, like what do you call that? Row frequency or row proportion you call it as?
Row relative frequency.
Row relative frequency. And similarly, you can have for the column also. So there, so the people that has their own phone, what's the proportion that? What is the proportion of the female in that? Like for example, there are 76 people that has a phone, right? So 34 out of 76 is female, right? Similarly, 1 minus 34 upon 76 is male. So this is the column proportion of the column relative frequency. But these are pretty simple questions. If you are getting this type of question in the exam, you don't have to do any mistake. These are just the bonus questions. And every year, I guess one question generally will be asked regarding the contingency table. You'll be given the table or the data. You'll have to create the table and give the answers for those questions. Or if you have been given the table, you'll be asked the questions, some simple questions. What the proportion of the female that own the phone, or what's the proportion out of the total people? How many of the what's the percentage of whole female and male that doesn't hold the phone? So that will be basically what 24 upon the 24%. 24% of the people doesn't has the phone. 76 1 minus 0.76 has doesn't have the phone, and 76% has the phone. Okay, this type of basic questions will be asked in the exam from the
Okay,
contingency table. Okay, is this
Okay,
clear?
sir.
Yeah. Any other question
Sir?
from the
Sir?
yeah?
Sir, but
For
in graded assignment, they are asking just 2 decimal values, sir. What can I do, sir?
Okay, 2 decimal. Okay, so you have to calculate and then put it the value, your answer up to 2 decimal. This is what you can do maximum. But I
Okay,
don't
sir.
think so. In the exam, there can be some questions, but not like maximum. You can get 1 or 2 questions where the decimal value will also be included. Even though the decimal will be included, your answer will be very nice, like 6.25, something like that. It won't be
Okay, sir.
some recurring value. Okay, so don't worry about that.
Okay, sir.
Yeah,
Sir?
yeah.
Sir, for the correlation for the point-wise serial correlation coefficient, the formula is y0 minus y1 divided by standard deviation into p0 into p0 whole root. But in some cases, we are using which? How do we know which one to code 0 and which one to code 1?
Anything you can do. Anything you can do. If you're just taking the mod value, it won't affect your answer.
So but then when we take the mod, then it will be positive always. So then there
That's
will not
fine.
be any negative. There will not be any negative correlation then.
So what? Like if your values, whether it's a negative or a positive, that doesn't make any sense. Like if your value it's like how close it is to 0, okay, or how close it is to 1. Okay, it's not about negative or positive. Okay, if this is -1, that means it is negatively correlated. It is correlated for sure, but negatively. One value is increasing, the other is decreasing. You got an idea, right? It is related to 0. That means like it is not correlated itself. Like it's very uncorrelated. The value of x and y are totally independent of itself. Okay, x is something else and y is something else. So there's no correlation between x and y. Okay, so in ML and all, you'll just have to pick all those values, all those. You can say the columns or the row if you're just taking based on what you are assuming. If you're assuming column as a feature, then you'll be just putting those. Like you just need those many features which are highly uncorrelated. Okay, so correlated you'll just throw it out because that are not important, because there are like one variable or one feature itself will give you an idea about, will give the model itself about the idea, like about the data set. Okay. Yeah. So it's not about, you just take the mod value and then calculate it. I don't think so they'll be asking you whether it's like a negative or a positive, for at least for this cases. For which case? For the wherever you are having, you have to pick out the correlation between the category and the numerical variable. Okay, because you'll get, because you don't have the luxury to choose which one. If they have given you the luxury to choose, like if they have given mentioned already that you have to take male as a 1 or 0, whatever, then we'll have to calculate because they have mentioned it. So that means they're asking you in the form of a negative and positive. If they're not mentioning anything, you can directly calculate with the help of the mod. Okay.
Okay, sir. Thank you.
Yeah. Thank you. Yeah. Any next question?
Sir, there's a question about Simpson's paradox.
Okay. Where like graded
It's in,
practice assignment.
practice assignment.
Practice which one? 3.2.
8th one. 4.2. 8th question of practice
4.2.
assignment.
Sorry.
4.2. 8th one. But for 8th one, I have to solve all the other questions. Okay, let's solve it from the starting then, I guess.
Sir, question 4.2 solve. Question number 1.
Okay, so what has been given here, let's discuss this then. So the information has been, okay, so everything has been defined, right? The Simpson paradox is defined as a reversal of conclusion in disaggregated and aggregated correlation cross W. So
Yes, sir, can you
the,
please explain the statement of the Simpson paradox, sir? That it has been written over there, but I'm not able to understand.
yeah, okay, so let me first understand that. And then you have been given the data, there's some form of a data has been given, and then capital A, capital B, total matches, home and away, everything has been given.
Sir, where are like
What?
Checking.
Hello, sir, I have a doubt regarding to mock test.
So, can you please mute yourself? Otherwise, so here,
I have a doubt regarding to mock test.
please.
Shraddha Singh, sir. It's Shraddha Singh.
So based on the data that has been given to you, which okay, all this is symbolized the result of the conclusion. Versus the index plus okay. So basically, I have been given some performance. One performance is home matches and away matches. Okay.
Okay, sir, I have a question regarding to mock test.
Mock we'll discuss in the end, but first of all, we'll just discuss this.
So how do you give
One second, yeah, please. 1 second. See that basically this whatever has been given here, I don't know whether it has been given clearly or not, but this basically means it's defined as the reversal of the whatever the conclusion that we are making from the data set is reversal of that. I guess this is what it means. Whenever see there are some data that has been given to you, whenever both the data has been combined, so that means aggregated, then your conclusion is totally opposite of whatever you were concluding before separating. Like you just concluded something, right? You have some data set and then you concluded something, but after combining all those data sets, your conclusion is getting reversed. This is what it means. And I guess this is what has been talked about, is defined as a reversal of conclusion in disaggregated and aggregated cross tabulation. And disaggregated performance, I guess, what is this disaggregated performance? I guess this is given regarding table 4.3. So whatever the table has been given, so you just have to, so I'm not showing any table, I'm just reading it from my laptop. Okay.
Sir, the best is, sir, can you check the solution of that, sir? You submit then check the solution, sir. Even the solution is not clear to me, sir. What was explained over there?
1 second, I'm just explaining the question and then we'll go to the solution. Okay.
Yes, sir.
Then we'll try to solve this problem.
Because in solution, they have individually calculated the table for this draw matches and this loss matches and this win,
This
and
is
then
what
they
I'm saying.
compared
This is what I'm saying. That basically
Yes, yes.
Simpson paradox, whatever they have defined it as a reversal of the conclusion in some separated data, and then you are just merging all those data. So basically, this index, whatever the paradox index, that basically defines you as a reversal of the conclusion that you have made earlier. So you have been given some data set, right? So the data, I guess, they are talking about is the home and away. So separately, they have given the home and away data set, and after mixing both home and away data set, now they are saying that the conclusion that we were making earlier is getting opposite. I think so. They are talking about this thing only. Let's read it.
Yes, sir, you are
carefully.
correct.
Correct, right?
Yes.
Okay. So let's read it nicely now. So this data set tells you about the disaggregated performance, and that disaggregated performance tells you about the home matches.
Question
What? Question
Question
number
number.
fourth to 8th, I guess, 4.2 practice assignment. Okay, and then the aggregated performance is both, I guess, that more both home and away of two Indian captain A and B. Okay, it has been given here. So now aggregated, they have defined everything. Aggregated data is the combination of the group of data into a single summary. It is given the home, okay, aggregated in the places where it's combined. Yeah. Now the first question is, you have been given, now you got the idea. So here it is just saying that Simpson paradox is defined as the reversal of the conclusion that you were making earlier, and now after combining all those data sets, whatever the conclusion that you are making, either it's a totally opposite. So the conclusion that you are making later is totally opposite of whatever you're making earlier. Now let's deal with the
Sir, my question is different, sir. Please share the screen, sir.
Okay, I can't share the screen. Can you send me the screenshot, Sam? Can somebody share me the screenshot? Because I don't have anything on the tab. Okay.
My question is guava, apple, orange, sir, something else.
Okay. Then I'll just share. I'll just try to put it as screenshot on my laptop. Maybe that will help. Okay.
Yeah, same. I had different question. Yes, sir, I have uploaded the screenshot.
One second. Is the same question?
Okay, can you tell me please how
The
to
screen
do
is not
the
visible.
Okay. Is it visible now?
Yes,
sir.
Okay, so this was the question that I was talking about. So here, okay. So what I was talking about, yeah. So this was the problem. It has been defined here. So Simpson, paradox. Here it has been clearly written here. So it is basically the reversal of the conclusion that you are making from the disaggregated or the separated data and the aggregated data. So this is what I guess that they're talking about the disaggregated performance as home matches and away matches. These are the home matches and away matches. And then you have mixed of both. So this is aggregated and this is the disaggregated data. Correct or not? Is this clear?
Yes,
to
sir.
you? Yeah.
Yes, sir.
Let's start with the fourth question. So from here itself, some question has been asked to you. So the fourth problem. What is the fourth problem? It's talking about based on the data that has been given, which captain has a better captaincy record, better record in ODI captaincy. Okay, then this is simple, right? You just calculate the percentage of win they have done. Correct? Better record in the ODI captaincy, and then they're asking whether A or B. So for the captain A, you can see that for the winning percentage, you can see that 9 and then. Okay, for the A, how many they have won out of how many they have won? 9 plus 76 plus 9, right? So basically 85 they have won.
85 upon 152. It's
Yeah,
total
85 upon whatever the, yeah. And then the other guy is,
55.92%.
yeah, 55.92 and then The other
And
is
for other one is
175.
60 upon
So
260.
this is 7. Yeah. So
Yes.
B, I guess, is correct. What is the next question? Which captain has the highest loss percentage in the ODI among the two? So that is pretty simple. Like you can just do like 1 minus of whatever they're winning. Oh no. There must be some a draw or something like that.
A draw match is okay.
Yeah, correct. So then you have to do it like lost 66 upon 152, and then you have 85 upon 260. So whatever you are getting, that will be the loss percentage. Now the sixth problem is which captain has the best win percentage in the home? So now you can see that at the home, how many have they have played and then how many they have won. Correct?
Yes.
So I guess the captain A has won 9 out of 10 is for A, and for B it is how many?
150 upon 200.
150
yeah.
upon 260.
200.
200, right? 150 plus 50, 200. Now the next question, which captain has the best winning percentage away ODI? Away ODI, away, you can check it from here. Now the important question is the 8th one, right? All the remaining questions are simple. The 8th one, what does that mean? The 8th one is saying that, does the above data illustrate whatever the Simpson paradox is? So now you can see that for the data, we have to calculate something, right? So we have calculated for captain A and captain B. We have calculated everything. What are the things that we have calculated? We have calculated in the home game. So we have to just check whether whatever we are concluding from the data, like the divided data, so home and away. What is the winning percentage of A? 90% was there, right? 9 out of 10. And for the away, it was 55.5. What is the away? What was, I guess this was the, okay, whole percentage. Away, it was 76. What is this? Yeah. Okay. So I don't have any other option. I can just mute everyone. Like I can't. If you just.
Sir, what is Simpson products?
Oh, that has been defined here. Like, see, Simpson product has been paradox, has been defined something like the reversal of the conclusion. So this is what I'm just trying to say that. See, this
I mean,
basically.
what is it actually?
So this is. So you are just making some conclusion upon some data set, okay? And then your conclusion that you have made after combining some data set, your conclusion was totally like it was not same as whatever you were making the conclusion. So here also it has defined. So this has not been taught, that just in the question itself it has been defined something like, so reversal of the conclusion in the differentiated data set and the aggregated. So whenever the different set of the home away was given, you were having some other conclusion, but whenever you're combining the data set, you have some other conclusion. So that is what we are checking here. Okay.
Okay.
Yeah. So you can see that for the home and away. So what is the winning percentage for the away for captain A?
53.52%.
Something like that. Okay, 55% something. And then for if you are combining both, okay, 53. And here, if you are combining some both,
55.92%.
then the winning percentage is 55.9. Okay, that is fine. And then for this case, it is for the home, we have calculated, right? 67. Okay, this is
75%.
75%.
41%.
41%, and then this is
67.30.
Yeah, so now you can see that but in the home the winning percentage is 90. Similarly, you have to okay, so the options, first of all, we have to check the options. So the options, the first, does the above data illustrate the Simpson paradox? Okay, so is this happening?
Yes, sir. Like we can comment over here, the sir. the captain A is winning at even at home and away, the percentage is higher than captain B. But in total, the observation has completely reversed because in total, the captain B is performing well than captain A.
Yeah, so yeah, for home matches you can say that the captain A. So if we just got the data for the home matches, we would have thought that captain A was having a winning percentage of 90% and captain B was having the winning percentage of 75% only. Correct?
Yes,
so for
sir.
the win, so yeah, so now we can conclude that for the home
It's
matches.
either way around because if you individually category wise see, A would be a better captain, but if you aggregate them, then it's a different story. That's the what paradox says.
Yeah, this is what it means. So whenever you are just taking out the data set like individually, there is some different conclusion, but if you are merging both the cases, your conclusion is totally different. Okay, so in the win percentage itself, you can see that in the win percentage that you can see that, right? The winning percentage for the captain A is very high as compared to captain B for the home matches, right?
Yes, sir.
And I guess for the away matches also, both the cases are high, right?
Yes, sir. That's what I said.
Because the number of games that they have played was very low. Okay, that doesn't like because the number of games, I guess, because of the number of games, because A has just did the captaincy for 10 matches and out of that 9 they have won, and similarly for the away matches also. So you can see that individually, if you'll see, A is performing well for home and away. But if you'll just aggregate those data sets, now you can see that the winning percentage for the B is much higher than that of the A, right? So our conclusion that we are making earlier is getting reversed, correct?
Yes.
So for the win percentage, so for the win, I guess the option C is totally correct. Option C is saying that, yeah, this is following the Simpson paradox because the reversal of conclusion occurs in the win percentage of the both captaincy. That we can see that, right? Now we have to check for the draw also. So similarly, you can plot this for the draw matches, and similarly you can draw for the loss. And then you have to check whether the aggregated data is different from the splitted data, or the conclusion that you are making from the splitted data is same as for the aggregated data. Okay, and if that is same, then you can say that there is no correlation. Like no correlation, I mean no, that's not following whatever you are saying, the Simpson paradox. And if there is a conclusion, reversal of the conclusion, then you can say like for the winning percentage, we can see that, right? For the winning percentage, the performance of A was looking much higher, but when we are comparing all those cases, the B was performing pretty well compared to the A. Is this clear, or should I repeat
yes,
it?
Yes, yes.
Clear for everyone, whoever has asked?
Sir, how to
Yes,
calculate
sir.
those aggregates, sir? Just so it had, sir.
But aggregated means this is total, right? So away, there were some home matches. So there is some captain A. He did captaincy at home and away. Okay, and after that we are merging both the cases. Now here there must be some matches he would have done the captaincy. Here also you would have done some captaincy, and so if we are adding both the matches, he would have done the captaincy in whole, right? Similarly for the B also. See why this is happening, because from the data itself you can see that, right? See from the data itself you can see that I get an idea. See, this guy, Captain A, was doing the captaincy just for the 10 matches at the home. And out of that, 9 he has won. Because the sample was very less. Because he just did the captaincy for the 10 matches, right? And away matches also, he did the captaincy for 76 plus 65. That is fine. Okay. Similarly, for Captain B, you can see that in the home, he has done almost 200 matches. And then out of 200, he won 150. Because the sample size is pretty high. Right?
Yes, yes.
Yeah. So that's why I guess from this data you can conclude that the conclusion that we are making for the splitted data is opposite to the conclusion that we'll make for the aggregated data.
Oh.
Yeah. Is there any doubt in this? You can ask me again. I'll just
Sir, can it be said that the ratio over here is quite a bit misleading?
Ratio, I mean the number of matches they have played or what?
Yeah, in that sense, let's say for example, the matches won by A is 9, which is out of 10. Because of that,
correct. This is what, yeah. So the number of match is not similar. Like the the match, the captain A has did the captaincy and B hasn't done similar number of, like there is a huge gap. That's why I guess one of the reason for happening this. Okay.
Okay, sir.
Okay, let's move to the next question. If you have any doubt in this, you can ask. Otherwise, we'll move to the next one. Next question, if you have.
Can you please explain how to do EMQ capacity assignment with
EMQ, I already told you. EMQ, you don't have to worry now. So, but I'll just give you an idea how to solve, like at least if you are just because, but in exam EMQ will not be asked till now, but in the next quiz it can be asked. So here some notation has been given to you that and the options has also been given to you, right? 1, 2, 3, 4, which of the okay, and then you have been given some questions, right? So from the given list of options, okay, which of the following, like while calculating, let's for example, you're calculating sample variance and population variance, okay, for any of the problem that has been given to you. So then from the list of options, which of the options you will be using as a formula to calculate this? You are not been asked to calculate the exact formula. You have been just asked to which of the following you will be using the concepts to calculate this, and this is what you have to write it. But even though this is not useful for now, for week 4, from week 5 we will be given a separate session how to deal with the EMQ session. Okay.
in the transfer, but my usually the
I can't hear you. Yeah, EMQ they will not be asking. That is what I just discussed and before the session itself, I got the information that the EMQ you'll have a separate session how to solve those EMQ like questions from week 5. Okay. But I just gave you an idea, like wherever the question, let's for example, you just have to calculate the sample variance and population variance. Okay, and then you have been given the formula. So the formula has been written in somewhat, I guess, the 3 or 4. Let's for example, you have been asked for calculating the sample variance. Okay, so maybe the formula number that has been given is 4 or 5. Okay, then you have to write it there. 4 I'll be using the formula to calculate that. Will not be asked to calculate the exact value. You have just been asked to which of the following options, like formulas or the techniques or the
Sir, I think there is a video already uploaded on this stats channel, sir. It explains how to handle EMQ. You can find it below EMQ only. Introduction related to bonus practice assignments. In there you will get it.
Sir, in this
Sir,
question, paradox question, the fourth question, you're supposed to take the aggregator only, or else can't we take the home for home? Why are taking only aggregator? Hello.
Okay. So whatever I said, so are you able to hear me now? Is it
Yeah,
okay? So we were discussing about the EMQ, and I told you that EMQ will not be asked till week 4. From week 5 will be asked. Even though I have discussed how to deal with that, but yeah, as of now you can just focus on the other things except EMQ. Yeah. Any other question from the week 4? Sorry.
Sir, best fitting line, sir, is it in the syllabus or not?
No, you don't have to worry about the best fit line. You will be taught about the best fit line.
Lecture 4.8, ma'am, has given some hint on this fitting of a line, and in activity 4.8, there is 1-2 questions related to it, sir. Can you discuss that also? Or it is irrelevant regarding considering
No, I'll have to check. Okay, how much it is like they haven't taught you how to get the best fit line, because those will be taught in the
yes, sir,
different elective.
Higher statistic.
But which question you are talking about?
Sir, this R squared, sir, in activity 4.8, question number 1 and question number 2.
Okay, so R square is what? What do you mean by how does that, whatever the line that you had, how measure of goodness of the fitting to that line? Okay, so whatever the data set that has been given to you, how the measure that is just checking how your data set is fitting your best fit line. Okay. Are you able to hear me?
Yes, sir, I'm able to hear.
Yes, sir.
Yes, sir. Okay, and R square is pretty like you can say that that you calculate coefficient, the correlation coefficient you calculate, right? If you're just squaring it, it's not the
Can you
exact, but
please mute all people? So many emojis.
Vishal Raj is there, Kalyan Jiam is there, something. Yes, sir, what you were saying, sir, did not catch it. Can you please
yeah,
say it
one
again?
second, I'll just ask them to make me, otherwise I'll just have to mute everyone, otherwise. So what I was saying about the R square, okay, so R square basically measures the goodness of how the data set how your data set is fitting the best fit line or the line that has been given to you. Okay.
Sir, if R squared is related to anything like related to covariance or correlation, something.
Yeah, that correlation coefficient that you calculate, right? If you do this, if you are calculating that small r, okay, and if you're doing that square of that, it will be almost like you can say that that is the R, the capital R square. Okay, not the exact thing, but you can just correlate in that way.
Okay.
Yeah.
So, sir, this
it will give you the same sense. It will give you the same sense if you are just calculating the correlation coefficient, square it. Okay, it will give you the same.
Okay.
Sense. Okay.
Okay. Sir, in the second statement, sir, it measures the goodness of the fit of the line of the data set. What does this actually mean, sir?
So, see, how
Measures
does see you got? I'm not able to share my screen. 1 second, and just ask them to make me the post again, so because my iPad got crashed. Like, okay, now until now they haven't made me the. Okay, till that time I'm just trying to tell you. See, you have some data set, right? Your data set, if you are just plotting that in a scatter plot, okay, let's for example is following some sort of a straight line, right? You got the best fit line.
Yes.
Okay, so the scatter, after plotting, just plotting the scatter plot, you just use some, maybe in the linear regression, how do you calculate? You just get your base fit line, you just calculate the perpendicular distance of all those points from some y equals to mx, some straight line that you choose, and then you calculate the you just basically you have an optimization problem where you try to solve that straight line such that this perpendicular distance from all those points is minimized. Okay, and after solving this method, you will get your best fit line for that data point that has been given to you. Okay.
Sir, but there are many clusters of point over there, sir. It is practically impossible to calculate the
no,
distance.
It is possible to calculate. You don't have to worry about that. It is possible to calculate. Okay, to see, minimize the distance. That doesn't mean you have to get the exact line. Minimize the data. Minimize the distance mean you have to get one of the best. Okay, you don't have to get the best. So in ML and all, there is nothing called best. You just have to get a better model. Okay, so here also best fit line generally basically if you have just two variable, and if you want to predict the weight, like you have a weight and height, okay, for some data point, okay, for some people, 1,000 people, and then whenever the 1,001st people come, you have to predict the weight of the person. How will you do that? You have some data set already, right? You have some scattered data set where the height and the weight has been given to you. Okay, you predict, like you have plotted that on a scatter plot, and you just want a best fit line that represents your data set. And then whenever the next people come whose data set I don't have, I just have the weight and I have to predict the weight. Okay, I have the height and I have to predict the weight. Okay, I'll just use that straight line equation only. I'll just put the value of x and I'll get the y. Are you getting me? Okay.
Yes.
So here R square generally tells you how your whatever the data set was given, how properly it's fixing or finding it fine for your straight line. So the best fit line you have calculated, and how like it's basically measuring the goodness, how good your data set is fitting to the best fit line. This is what has been measured. Okay. And if your R is very high, that means it is measuring. If your R is very high, that means it's very highly correlated. Your data set is highly correlated to that straight line. That is the best fit line.
Sir,
Yes.
I have sent one question inside chat, sir. Please reply.
Thank you.
Okay. But that is not related. Like you just have to know that it generally basically measures the how nicely it is your data set is correlated to your straight line. Is like the best fit line.
Means how many cluster points are you more together towards the line, sir?
See, there can be a straight line even though there is no data point that is lying on the straight line, and that can be a better compared to. I am really sorry, I'm not able to share my screen. Just wait for 2 minutes. Maybe after that I'll be in the better position to explain you.
Sir, suppose there is a the points are in circular format. We know that in general there will be no relation between both the variables, and we draw a perfect line that is very close to all those points, sir. Will we say that is the measure of the good fitness of a line, sir?
Please share a screen.
Just give me 1 second. I just want to share my screen. I'm not able to.
Okay.
Okay, so I guess he's not picking the call. Okay, maybe he'll do that. Just give me 1 more minute. Okay, now I'm able to share my screen. Are you able to see my screen now?
No, sir.
Okay, so what I was saying is, now you can see, right?
Yes, yes, sir.
So let's, for example, this is a straight line, the best fit line corresponding to your data set. Your data set is somewhat like this. Okay, so you can see that. Okay, and now tell me which of the following is the one or two we can think of as a where your best fit line is a good resemblance of your data set.
One.
Right? Even though there are some data point that is there in the line, that doesn't mean your data the line that is given to you, the fitting line, is good resemblance of your scattered like the data point. This can be on. See, basically what generally you do to calculate the best fit line is like one of the method. Basically, that can be one of the method. You calculate the distance, right? D1, D2, all the distance from your data point. Okay. Let's, for example, you just take one straight line itself, y equals to mx plus, or maybe one straight line, you just take it out, because you just need what? You just need a slope of that line, right? If you have the slope of the line and the c value, you can directly calculate the straight line itself. Okay, let's, for example, this is x and this is y. So you are having some height and weight, okay, and you have the data point. So you just solve this problem. So whatever the problem that you have been given, okay, you try to solve this. You calculate the distance from each of the data point. Okay, you randomly take out the data
Smaller
point.
slope
It
give
can be in number
accurate
of
lines, sir.
what?
Smaller slope gives accurate lines, sir. Right?
Give the example, sir.
No. So okay. So what I'm trying to say is, how do you calculate the best fit line? It's relevant for exam. First of all, I'm telling you, you're not going to. Nobody is going to ask you. I'm just giving an idea that whenever the data points itself is not resembling, like this, I was saying. What?
He's asking for example.
Oh, this is example only.
Okay, sir.
Okay, so this is the example only. I'm giving you two examples where in the first case, you can see that you can think of as a R square is very low, and in the second case, in the first case, you can think of as a R square is very high as compared to the second case, because you can see that your data points is giving a good resemblance to your best fit line, but in the second case, it doesn't give you. Okay, and then basically one more question, if you have, how do you calculate the best fit line? One of the method basically is you calculate the distance. Okay, the perpendicular distance you calculate from your line. So you just assumed one line, okay, y equals to mx plus c, and then you calculate the distance, and then you just minimize your distance. So whatever the distance that you have calculated, di, so perpendicular distance from each of the data point, you calculate the summation, and then you minimize this. So this is your problem that you want to solve.
Which axis, sir? Sir, from which axis perpendicular distance?
Which axis means like you straight line you have, right? You calculate the perpendicular distance. This is your optimization problem. So optimization problem, see, from y equals to mx plus c, you have what you have to know. You have to know m and c. So basically, you need two variable, right? And this is your problem. So this is your problem, and you calculate the distance d1, d2, d3, and do the summation for all those values, and then you want to minimize that. You have 2-3 variables. You don't worry about that. They are methods that we solve. Okay, there are gradient descent and all those methods to solve this type of problem. Okay. So, but
sir,
that has not been taught. That has not been taught for you. How do you get? You have, if you have been asked the question, you'll be given the best fit line itself directly. And then I don't know which type of question they'll be asking you from the best fit line. They can maximum ask you R square. That is what. And in that also the theoretical question. Okay. Or maybe the small r has been given. What can be the value of R square? Those type of problems can be asked maximum. Nothing more, nothing less. Okay.
Sir, suppose we draw, data of correlation coefficient of 0. So it will be basically a cluster of point in the middle of the graph, x and y axis. And we draw a line that is parallel to x axis, and it almost touches, the graph.
If you have been given the 4 type of data can be given, right? 4 type, like maybe the data set can be something like this.
Yes, sir, increasing.
Okay. Or the data point can be something like this. Or your data point can be something like this, random, very random. Okay. So this 3 type of data point can be there. Anything else? Or maybe there can be very sharp data points like this. The all your data points will resemble on a straight line. Can you tell me the value of R for all those cases?
Sir, for the first one, it is R equals to 1. This one, sir.
Almost equals to 1.
Almost.
Here it will be almost more than maybe 0.7 or 0.8, greater than 0.7 or 8. Here it will be like minus maybe 0.8 or 0.9, something like that. Here it will be almost 0. Because this like x and y is totally unrelated. When the value of x was this, the value of y was this. When the x value is this, the y value. So this is totally unrelated. Okay.
Yes. Sir. So suppose here in the unrelated one we draw a line, and all the point is just close to that line, sir. Can we say that line is the best fit? Because it will make no sense in that case, because both the...
Yeah, you can say that, but I told you, right, there is nothing called best in this type of a problem.
Yes, sir. Yes, sir.
Okay. You can calculate, there can be a different method to calculate the best. You can calculate the distance method that I told, but there can be a data set. Those are not numerical itself. Those will be totally different. And then what will you do? So there are methods to calculate the best fit line in those cases also, right? So there can be values like DNA samples. Okay, so there can be, so we are just talking about the numerical data set, and the numerical data set, whenever you are calculating the best fit line, there can be, this is the one method that I told you. But even though you don't have to worry about the method, how do you solve that method? You just have to know if you have been given the R, how it is correlated, how is the data set correlated to that, how is the X and Y related? Those type of things will be asked, nothing more than that. Okay.
Sir, because this question came in my mind with this value of R equals to 0. You said that if we square this value, we get the value of capital R. So in that case, capital R will also have a value of 0 only.
R, that also will be, like, it's not exact R square. Okay, I'm just giving an idea. If you have been stuck.
Okay, I got it. I got it.
Not the same thing, but it is like, will resemble the same thing. Okay, the significance for both the cases are same. Okay, but whenever you have a R equals to 0, that means it's totally unrelated, the data set that you have. Okay.
Okay, sir. Okay.
Is it clear to everyone?
Sir?
Yeah.
Small R square is equal to capital R, correct?
Yeah, you can think of it in that way. Yeah. The significance for both the cases are same. Yeah.
But then in some questions, they have given capital R square.
Huh? So
what does that mean?
So capital R square only I'm talking about. The small R square. So what you are talking? So which question? Can you tell me the question number?
Sir, you're right. Sir, on the screen, you're right. Sir, I will tell you something. -1.
-1.
Less than equal to small r.
Less than
equal to small r. This
okay, you just
correlation coefficient, sir.
This is what you're talking. Sorry.
This side will be 1, sir.
This is what you're talking.
Yes, sir. Now square everything, sir. You will get the answer 0 less than equal to capital R less than equal to 1.
Then that is fine, no? That is like R square will be from 0 to 1, and this is what you know.
So that is small r square, not capital R square.
It's capital R only.
Capital R square.
Both are same, R square and capital R square.
Almost same
Best
only.
fit square is almost same as correlation square.
But what is the difference between small letter and capital K?
Small is correlation and capital is best fit line.
See, R square, the capital R square. Have you been taught about the small R?
The capital R is meaning.
No, sir. In actually,
is that been taught? Is that
no, sir.
Taught? Small R square has been no, right? Capital R only has been taught. So why are you like worrying about all those things? The small r that you have been told is basically the correlation coefficient between X and Y. Capital R squared that you know small. Okay, so I'll just write it out. So small r, what has been taught is this is what the correlation coefficient, right? So if you have X and Y, what's how the X and Y is correlated? Okay, so this is unitless. Okay, then R square. This is basically if you have been given some best fit line. Okay, then basically R square will capture how your data set was correlated to that straight line that has been given to you. It basically measures the goodness of the fit measure. Okay. If your data is R square is from like if it is closer to 1, that means your data set that has been given and the best fit line captures your data. Your best fit line basically captures the huge chunk of your data point. And if it is nearer to 1 and if it is nearer to 0, that means whatever the best fit line that you have, it's not capturing the data set. Okay.
Okay, sir. I got it, sir.
Okay. It's pretty simple. You don't have to get confused in that. Okay.
Yes.
Yeah.
But sir, is there any way to to calculate R, or it's just a symbol?
Which R? It's capital R you're talking about.
Yes, sir.
So see, starting from like whenever you calculate the small r, right, the correlation coefficient, many times.
Sir, I think, sir, it will come in the when we will study about the regression of the line, sir.
So regression will not be taught here. So regression.
No, sir, it is not in here, sir. Other classes.
But see, till now you can just think of as a correlation coefficient as the small r, okay, and the capital R generally basically gives you how good your data set is fitting the best fit line. Okay.
Correct, sir. But is there any right?
But you will not be asked to calculate. I am pretty sure. I am pretty sure you will not be asked to calculate it in an exam. Okay.
Okay, sir. Okay, sir. Fine, sir.
Sorry, sir, to interrupt you, but I wasn't able to join the meeting. So recording will be available or something?
Yeah, recording will be available. So it's there on the YouTube. So it is available.
Okay, so thank you. Sorry.
Okay, no problem. Anything else from the week 6? Sorry, week 4 I'm talking about. Week 4.
Sir, just have sent you one image in chat, sir. It's old questions, I guess.
So I'm telling you, old question, please, you can just save it for the revision session. We'll be discussing all those questions in the revision session.
Sir, when
Okay?
will it, sir, when will
This will happen, I guess, in the next upcoming 2nd July or 3rd. It will happen. Okay. So 3
Okay.
sessions
Sir,
we have scheduled just for the previous weeks only, from week 1 to 4. Okay. So you'll be having some more sessions before the exam. We'll just be solving problems only in those cases. Okay. You don't have
sir,
to worry.
will we take mock in those sessions?
Mock also will be, yeah, mock also will be discussed. Each and every question from the mock will be discussed in one of the session. I guess that is scheduled on Thursday.
Sir, in the contingency table, so there is a row relative and column relative frequencies, and
Correct.
just give us hints. Actually, the question will be a little bit tricky, and sometimes I'm considering if they're asking column relative frequency, I'm tending to the row relative frequency, so that my answers are might wrong. So that can you just give us a hint with any example, because it was in a graded assignment. 1 or 2 questions were wrong after I realized, so that I changed it. So is there any hint to get to know clearly?
No, but they'll not be asking directly the row frequency or something like that. They'll be asking you some questions where you have to think of what should I calculate, right?
Yeah, that's what I'm asking,
Did
sir.
they ask you directly the row? Did they ask
No,
you
no, they
directly
won't
the row?
ask. But we supposed to understand that.
Correct. So let's, for example, you have one problem that I was talking about. So in this problem itself, you have been given the data set. I'm just asking you, what will you do if I'm just asking out of the people, of the whole people?
Are you showing a screen?
Is it not visible?
No, no.
No, sir.
No.
Okay.
Yes, sir.
Yeah, is it visible now?
Yeah, no. It's
Yes, sir.
Okay. So what I was saying is, okay. So from the table that has been given to you in front of you, so if I'm asking out of the like, what percentage of female own a smartphone? What will you do? Like basically you'll do what if I'm just asking what percentage of female is having the phone, like is owning the phone. Okay, you'll just see basically 34, right? So you'll be calculating
34,
row
yes.
or column frequency.
Row related frequency.
Row, right? Because and
Yes.
that is like irrelevant. You don't have to think of as a row frequency or the column frequency. Whatever has been given to you, just think in that way. Okay. So because
Yeah,
many
the question he was talking about, everything is mentioned clearly in the questions. Like he just have to focus on the questions. Everything is clear.
So female, what is the percentage of female own the phone? So I
Phone.
just calculating on the total. So 100 sometimes I tend to know
that you don't have
percentage.
to. That you don't have to.
That
you
is
don't
what
have to.
my query. Yes.
Okay, so that for that you just have to, like, I guess maybe the questions you just have to read it carefully, because see, many people can get confused. There is no problem in that, because yeah, in starting maybe there can be issue, but if you just reading the question and then understanding. So if I'm asking what percentage of female is having the phone, what percentage of female? So I'm just asking in the female itself, what is the percentage that yeah, out of 44, 34 is having the phone. So
34 is serving.
34 upon 44 should be the answer. And if I'm asking out of the total people, what is the percentage
yeah.
of people? Yeah, then
So 34 divided by 100, 34%.
Okay, and if they are asking you what percentage of women out of the total people, then you will be doing 34 upon 100 or something like that. Okay. But if they'll not be asking in that way, they'll be just asking what percentage of female itself is holding or having the phone or not having the phone. That means 10 upon 44. Okay.
Okay.
And if they have to ask you the column frequency, then they'll be asking you out of the people who are owning a smartphone, what percentage of that is a female, right? So the question, I'll just rephrase
That
it.
would be
So
34 by
34 divided by
76.
76.
Correct,
Yes.
76. That means out of the whole people, like out of the people who are owning the smartphone, what percentage is the female? Like that you have to tell. Then, so from the question perspective, that means just asking about out of the total people who has the smartphone. That means the 76. Out of that, 34 is female. So you have to calculate that percentage, 34 upon 76. Okay.
But I've seen few questions, sir, in mock also, sir, and not mocks, sir, some PYQ, sir. The questions are not this much straightforward, sir. It's really, you will have to use your head to understand what.
Yeah, that is what I'm saying. This is very simple, and if that is a multiple of data, we tend to confuse, and it is a little bit tricky. That's what I have tried to say. Yes.
Not little bit. It's very tricky actually over there.
Okay, so that maybe you can come up with your question. Maybe previous term ka just solve it and then come up with your question in the next, whenever we'll do the revision session. So maybe
Yes,
we
sir.
can
Okay,
just solve those questions itself in that session. That we can do. Okay.
Okay, sir.
Hello, sir.
Yeah.
Sir, can you explain the week 4 practice assignment 1 and question number 4?
Practice assignment 4.2, question number 4.1, question number?
Question number 4.
Okay, question number 4.
Sir, questions keep changing in practice assignments, so make sure to confirm the questions.
Okay, is this a question related to something like correlation coefficient?
Yes, sir. Yes.
I mean, this like product has been given, then calories and fat has been given. Is this the same question?
Yeah.
Or the...
Yes, sir. Yes, sir. Same question.
Okay. So here, so see, from the question itself, you can directly say that. So you don't have to even see the data for this case. If you have the calories and the fat is like totally highly correlated, right? Okay, but even though we'll just try to solve it. Let's see that. So what is the issue? You just have to, I think so, if this type of problem will be, even 2 problems will be asked, will be totally gone in the exam. But I don't think so they'll be asking you this type of problem in the exam. But let's solve this. So you have been given some data set A. So these are the product C, D, and something E, F, and G. So calories has been given 6, 240, 280, 260, I guess, 260, 350, 350, and then 420, 510, 530, and then the fat. Okay, so it's just asking that how is this both correlated, the calories and the fat. Okay, so for fat also the data has been given 13, 16, 19, 20, 25, 40. So one thing you can get an idea, right? Even though if you just from the option itself you want to mark, okay, if you want to mark, can you mark A option? I'm just asking you, you don't have to calculate. Even though you can calculate, you can get it, but that will take some 10 minutes. I'm just asking you from the options from the A and B, just check it. If the data is increasing, if one variable increasing, either the second one is increasing or decreasing. Can you get an idea? So let's start with the first one. The first thing. So this was 15 and you got 240. The data decreased, and then the other one increased. Okay, that is fine. Then move to the third one. From 15 to 16, it has increased, and the value that has increased from 240 to 350. Okay. Again, you see from 15 to 19, it has increased, and again it was constant. Okay, so you can, if you want to do the scatter plotting of this, you can just scatter plot. So 15, if it was 15, the value was somewhat 240. If this was 13, let's for example, this is 13 and the data was 260, somewhat like here. Okay. And then again 16. So if this is 16, the data was increased to 350. For the 19, it is here. Again, for the 20, you can think of as what is the value corresponding to 2420. So here 25, 510. You can just think of 45. You can see that. What do you think should be the value for this R? The option is being given
Positive.
26 and R equals to positive. So positive anybody can say. I'm talking about this will be positive. But what about the value? The options given for you is 0.26 and 0.86. Which of the first? 0.86, right?
Between 0.5 to 0.8.
Somewhat like this. So the option given is 0.86, right? So you can directly mark it as the answer. You don't have to calculate also if you are getting this type of a problem in the exam. Okay, and if they are giving, yeah, so if they're giving this type of problem, they'll give you for sure something like that, 1 for 5, then 2 for 10, something like that, so that from the data itself you can get an idea and can mark it, the R value. You don't have to calculate, because calculating the value will take a lot of time. Maybe 10 minutes you will just calculate it, right? Okay.
Sir, suppose the options. Suppose the options are given in such a way that
options can't be close enough. Now, options can't be close enough. If the options are close enough, that means they're just asking you to not solve this question. Okay? Or maybe skip that question. This is what they try to. So options can't be 0.8, 0.84. This can't be the option, right? Or maybe 0.7 also. They can't give this type of. The options will be very wide, like 0.2, 0.8, something like that. So that even though if you're not solving, you can get an idea. But if you want to solve, somebody wants to get an exact answer, you can get it, right? You have the method, you have the formula, calculate the covariance of xy, calculate what is the formula for that?
Standard deviation of x and standard
deviation for x and standard deviation of y. Calculate all those things, you'll get the answer. But why, if the options, or if this from the seeing itself, we can see that as the value of the fat is increasing, the calories also, or the calories increasing, fat is increasing. Then you can directly say that it's highly correlated. Okay.
Sir, yes, sir, I got it. Sir, there are also a few questions where it is either the correlation coefficients are, there are certain examples given: positive, negative, moderate, high, this weak, and this one. In that case, sir, how will?
What will you say about this? What will you say about this? This is weak or strong correlation?
This is a strong, sir, but moderate, sir.
It's a strong only. This is a strong 0.8. That means it's a strong only.
0.75 above.
There is no exact value that it is less than some value, constant value. But if this is greater than some 0.85, you can say that it's a strong correlation.
No, sir. This is what I said. We know the coefficient over here, so we said that it is strong. But if we don't know, we simply have the data over here, then how can we make an assumption that whether it is strong or it is weak, sir? In that case, we will have to calculate, sir. Can you give, sir, any hint on how to solve those questions, sir?
No, those questions, they can't give you something like if the values are from 0.8 or 0. If, let's, for example, you're getting R equals to 0.7. Okay, so what should
sir, in the same questions of practice assignment, there is a age given of this daughter.
Question
and
which one? Which question?
Sir, table 2, sir, 4.1. Sir, same question which I have asked you, sir, right now. 4.1. 4.1 table 2, sir. Father IQ and daughter IQ is given over.
Okay, father IQ and daughter IQ. It will be highly correlated. I don't know, but I didn't check the question. But I don't have that question itself.
Yes. Okay, sir. Can I share the screenshot, sir?
You just share the screenshot. But that depends. See, I just directly told you because it's like a. Okay, but you send me the data set. Then only we can. After seeing the data set, we can give you an idea.
Yes, sir. I have uploaded, sir. Uploaded.
Are my screen visible?
No.
Is mute itself. Okay, is this visible now?
Yes, sir.
Yes. Which question? This question you're talking about?
Yes, sir. Here, sir. How will make an assumption over here, sir, in this case?
Assumption if you have to make. Okay, let's start with the first 130 and 108. Okay, and then you have. Can you see any very highly see the first option is very strong, no correlation, positive, negative. Okay, so there must be two answers for sure. One from the weak and strong, and one from the positive and negative.
So this is one, sir. One is increasing, then next is decreasing, and again, sir, this is the pattern it is following over.
Okay, 1 second. So if this is 130, if you just want to, okay, I can't write it here. Okay, let's write it here. Just give me the data. I'll just mark it as a father IQ as something. See, this method that I'm telling you, if the options are very far away, then you can mark it. If the options are very close, then you have to calculate it. But mostly they'll not be asking you to calculate because you don't have that much time to calculate. So one is the father IQ. and there's this daughter IQ, I guess. So what is the first point? 130, right? 130? What was
130,
the value? 100,
108.
108. Okay.
Another point is
What is the other case?
100 and 107.
This is 100. 100 and
107. 17.
117. Okay.
Third one is
What is the
124.
other case? 174.
124, sir. 124 and 112.
Okay.
So can we bring a graph sheet to the exam hall? Is it okay?
Graphs? No, you can't bring anything from the outside.
Then the graph things are supposed to visualize only.
But you can't bring it, like it's a rule, like you can't bring it. What is the other case? 189, right? What was the other thing?
89 and 115.
Okay.
And then it is
132 and 100.
132 and 100. And then it is 99 and 102.
99 and 102. This is like, I don't know. It's like you have to calculate because you can't get anything from here.
This is what I was asking, sir.
This is
The
messed up data. Yeah. So for
messed
this
up data,
case,
sir.
yeah, this is messed up. Yeah, you can't get an idea. You have to calculate it. But what I'm saying is this type of data mostly like very high chance. Have you got any questions? You can just go through the previous term paper. That can give you an idea like whether there can be any type of questions like this.
Sir, I've got this same question 2-3 times in the practice assignment only, sir.
I'm talking about the practice assignment. I'm talking about the previous term
PYQ.
data. PYQ.
Okay.
See, practice
Like, sir,
is for the practice, okay? But yeah.
will there be, sir, questions like we will be asked to calculate the correlation coefficients, because it is very tedious to calculate that, it's very.
But even though if it is given, the values will be pretty simple, okay?
Yes. Correlation coefficient,
Mostly
because
what I'm trying to say is mostly you'll not be getting any questions like that, okay? Okay, one
Okay,
second.
sir.
Mhm. Okay. What's that? Yeah. One second. Just give me 1 second.
Okay.
Okay. So yeah. So this was I was talking. So what I was saying is we'll not be getting any questions that will be very difficult to calculate. So mostly they'll check you they're not checking the calculation part. They'll check you how did you understand the concepts and all. Okay. So they'll not be. I can tell you that there won't be any question where the data set will be very big and then you'll have to calculate the covariance, correlation coefficient. In such cases, no. You will be given some sort of a plot and then you will be asked whether. Can you tell me how is this R, like whether, how is the value of R, what can be the value of R? Okay, this type of things can be given. What can be the value of R means if you have been given the data, like if you have been given the plot or the graph, this graph will be such, the graph will resemble you. If this is a totally a straight line that is like with the positive x-axis, with like making some theta or that, like your data set basically is lying around your straight line itself, okay, then you can directly say that, right, the R will be, and then the option can be 0.9. So you can directly mark it as. So this is what I'm telling you. So the graph or the data set will be given in such a way that if you know the basic idea or the concept is there is the clarity in the concept, you can directly mark it as. They will not be asking you, they'll not be giving you the data and then you have to calculate. That will be a very tedious work to calculate it in the exam because you don't have the calculator also. You have the calculator, but that again takes a lot of time to calculate. Like again in the PC calculator, that really takes a lot of time. Okay.
Okay, sir.
Yeah.
Thank
So
you, sir.
this is what I can assure you. You'll not be, even though if you just go through the previous sum. So the best thing, the best friend for you from now onwards for the upcoming 7-6 days, whatever you have till the qualifier exam, just go through the previous term papers. That will give you the best idea.
Sir,
Yeah.
where can we get them?
You don't have the previous term data set. You don't previous term paper. You don't have. There's okay. If you don't,
Where can we get, sir?
no, people generally somehow find like there are some people who generally upload it on some site and all. I don't have been like that link and all for the site, but generally most of the people, I guess your colleagues will be having. You can just ask you some of the people. And if you don't have, then
marking in the qualifier exam?
what?
Will there be negative marking in the qualifier exam?
No, there is no negative marking as such, but for MSQ, if you're just marking one wrong, your answer will be zero. Like, will not be getting any, will not be awarded any marks, but there won't be any negative also. Okay?
Yes, sir.
Okay.
Sir, is the session over? Or is there something?
Yeah, so if we don't have any other doubts from the week 4, we'll just close it off. I have, like, I guess some maths or some other session is also happening. Okay.
Maths class is live, sir. now.
We have maths class.
Yes. Okay, is this started?
Yes, sir, it is started, sir. 8 o'clock.
Okay, okay.
No, sir,
Okay.
still not started yet.
Okay, no problem. So, yeah. So we'll again meet in the next session. I guess that is the revision session. I guess one more session you have for the solve with us, I guess, for week 4. And then we'll have some, I guess, the schedule session. You'll get regarding the schedule, I guess, in maybe tomorrow or day after tomorrow about the upcoming session for the stats and maths. Okay. So the revision session that has been scheduled. So do join those session and we'll just solve the problem from the previous term, and then we'll try to discuss the most important portion that we think of you should be knowing. Okay.
Thank you, sir. Good night, sir. Good night.
Contact you if we have any doubts.
Discourse you don't have. Discourse forum you can use it. Discussion forum you can use it. Okay.
No, sir. Can we contact you directly if we have any doubt?
That is basically you can mail me regarding your doubts. Okay.
Can you give your email ID?
So, but you don't have to spam, like nobody should spam there. Then again, it will be like I'll just write it in the chat box. But yeah.
The scheduled classes are as usual calendar schedule, right? Is there any special? No, nothing.
No. Up till now, the schedule session regarding the upcoming for the next week will be sent, I guess, by Monday. Tomorrow it will be sent for the extra session that has been scheduled before the exam.
Okay,
But
okay. Not
the
as,
normal
not
session,
as usual.
yeah, the
classes.
normal session will happen as usual, but the extra session, you'll get the information regarding that by tomorrow.
Thank you, thank you. Thank you, sir.
Sir, is there any one-shot lectures for this?
For what? One shot session?
He say one
Yes,
shot.
sir, one-shot lecture.
Yeah, revision session we'll discuss all week 1 to 4. This is what maximum you can do, like we can do it. We'll just discuss all the concept important portions from week 1 to 4. Okay?
Okay, sir.
Yeah.
Thank you, sir.
Thanks
Thank you,
everyone
sir.
for joining
Have
the
a nice
session.
day.
Okay.
Thank you, sir.
Have a nice day. Yeah. Okay.
Thank you, sir.
Yeah. Thanks everyone. Bye.
Thank you, sir.